appreciate it. It feels really, really good to be back, so I really appreciate the invitation. Yes. So yeah, today I'm going to present some work from my doctoral thesis that is using some relatively novel tools to assess students' understanding of proof. I thought what I would first do is perhaps give a little brief overview of what we're going to try and do. I'm going to try and present results from 2 different papers. If I don't get to the second paper, accept my apologies now. And then we'll talk about some sort of ongoing work and where this stuff might go. This is very much proof of concept work and very much sort of early trying to establish a new methodology style work. So those are the ambitions that we're setting out for. So I don't need that slide because Phil's just presented that slide very nicely for me. But this is me in a nutshell, and that is an embarrassing photo from a Frisbee tournament that I was at 2 years ago. So here's the work that I've been doing recently. So this is what we're going to talk about today. I won't dwell on that now, and some colleagues from various places that I work with. Some of you might remember Nikki Infante, who was supposed to be here for 6 months and was here for not as long as she might have hoped early last year. But we've been doing some work with some colleagues at Loughborough on oral assessment as well and trying to establish some protocols around what it looks like to use oral assessment in the English-speaking world for proof. This is some work with my doctoral advisor on some more methodological aspects of things we'll talk about today. And then some more kind of philosophy of mathematical practice stuff that I've been doing with a Dutch philosopher who I also came across in Loughborough. That says Belgium because he's moved, I think he moved literally yesterday to a new post in Belgium. But this is kind of just a flavour of the kinds of things that I spend my time on these days. Oh, and one more that very surprisingly is coming at the top, which is actually the thrust of my new job at UCL, which is designing automated assessments for their undergraduate program. If we have time, I might talk very briefly about what that looks like and perhaps some research opportunities embedded in there. But so on to today's business, or not. Perhaps on to today's business. We're going to live here for the rest of the day. Phil, help. Oh, thanks, Phil. So this is the paper that came out late last year, and we're going to spend most of our time trying to understand some of these key ideas in this top right-hand corner. Wow, that mouse is all over the place. So we'll talk about reliability and validity. We'll talk in particular in quite a lot of detail about what I mean by a proof summary and why I think this might be a useful task to look into. We'll talk about comparative judgement, which I understand is an assessment tool that is relatively new in this country. I know Jodie Hunter has been working a little bit with it in primary school education, but for the most part I'm going to assume that that's new. And then we'll talk very briefly about some proof comprehension literature. With that in mind, this is a very, very brief overview of my understanding of the proof literature. Students struggle with construction tasks. There are various reasons why our students are bad at constructing proofs. Here are some of them. Students also struggle to understand proofs that they read. Here are some reasons why people struggle with them. Said even shorter, students are bad at constructing proofs, verifying and evaluating proofs, and understanding proofs that they read. Okay, sure, this is sort of an opportunity for a hashtag not all students moment, but by and large, these are problems that we see in the literature. Similarly, we, the education community, are also bad at evaluating students' proofs, and this is more where my world lives or where my research interests lie, and in particular in evaluating students' understanding of the proof that they read. So this is kind of the target of this is the gap in the literature that we're trying to address. And then this last little caveat, well, if I say our students are bad, then perhaps I should put it on us and say, well, perhaps it's us that's not perhaps somehow failing our students. But in particular, I want to focus on the second to last bullet point. This is where we're going to spend our time today, thinking about evaluating students' understanding. And we're going to do so using the law of comparative judgment. So I'm going to assume this is relatively new to most people. And it's essentially this premise that, so if I was to hand this pen around the room and ask you, how much does it weigh? And ask you to write down some value in grams. Without being rude, you're probably pretty bad at that task. We'd all write down different numbers. Okay, sure, they'd be similar perhaps, but we're not very good at that task. If I hand around 2 pens and ask you which one's heavier, you're probably quite good at that task. There's somehow this innate human ability perhaps to do sort of paired comparisons versus isolated comparisons. Why might that be useful? Well, okay, now let's pretend that I have 10 pens and I want to know the relative weightings of all of these 10 pens. It's an extremely boring task, but perhaps we needed this. Instead of handing around the 10 pens, asking everybody to write down a weight for these things, and then taking some average of each. Perhaps I'll ask you to do a series of paired comparisons, and the one that keeps winning those paired comparisons is probably the heaviest one. Similarly, the one that keeps losing is probably the lightest one. And we can generate some kind of statistical metric that will give me, okay, an approximation. It's not going to tell me anything in grams, right? But it's going to tell me something about which one was heaviest and which one was lightest. Maybe we can apply this in education land where we don't have particularly good, robust rubrics or evaluation mechanisms for example, students' understanding. My claim is that proof is one such area. And I'm not going to justify it, I'm just going to claim it. So there we go. So in more detail, here's what comparative judgment looks like. We'll usually ask experts to make a series of pairwise comparisons. When I say experts, I'm intentionally quite vague there. The literature seems to suggest that it doesn't really matter how qualified our judges are, within reason. Okay, sure, if I asked a bunch of monkeys to do the pairwise comparisons, it probably wouldn't work. So we're going to use this binary decision metric, and we're going to use the Bradley-Terry model for those of you that are interested in rash analysis. I suspect that's none of you, but if you are, it's the Bradley-Terry model. And it's going to yield a score for each isolated response, or in the case of the example, each isolated pen. We're not married to assessment rubrics. We've already talked about this. This can be nice for a variety of reasons, but I highlight two here. That means that we can be more flexible with our task design. And we really don't have to think very carefully before we give the task about what a good response looks like. That's what I mean by we're not restricted by rubrics. And okay, here, so we claim that our scores are grounded in the collective expertise of the judges. This is sort of the converse of saying that we don't have robust rubrics and we don't need them. So that is comparative judgment, and that is sort of the premise on which we're going to be using for the rest of this talk. So if there are questions on that methodological aspect, I invite them now. Otherwise, it's going to get hairy. Fabulous. We're not going to do any heavy-duty statistics, I promise, because it's very boring. But okay, so now let's move on to, okay, so we've got an assessment mechanism. What is the task that we're going to talk about? We're going to use what I call proof summaries. Why am I looking for them? Well, we know, as we talked about, proof comprehension is difficult to assess. And in fact, further than that, proof is actually quite difficult to define. If I asked each of you to write down a definition of proof, you would probably all write different things. Maybe they'd be related, maybe there'd be some overlap. But by and large, we as the mathematics community, as the education community, and even the philosophy community, are very bad at agreeing on what we mean by proof. So unsurprisingly, it's not particularly easy to assess. Comparative judgment likes a diverse range of responses. If I ask students to summarize a proof versus just ask them to prove a theorem, then I'm probably going to get slightly wider diversity of responses. Otherwise, we're just going to get a series of perhaps correct proofs, a series of nonsense proofs, and we're not going to learn a ton from doing this pairwise comparison. This last bullet point, I put question marks because I have absolutely no empirical evidence to claim this, but I'm going to claim it anyway. I think that summarizing proofs is probably a useful pedagogic activity. It's probably somehow it helps students access or think about the way that they're reading the proofs that they are reading. That's some future research, but I sort of part of my motivation for using summaries. So what do I mean more precisely by a summary? This is the task that students get given verbatim. Summarize the given proof. So you've all got a handout in front of you, I hope. Is that a lie to anybody? Fabulous. So they would actually see this proof. They'd have it in real time in front of them. And they're asked to summarize the given proof in 40 words or fewer. Note, you are not being asked to reproduce the proof. So we're trying to avoid the notion where students will just give me the same thing back verbatim. And those are the best responses are those that succinctly communicate the most important ideas in the proof. So more specifically, theoretically, what do I mean? Okay, sure. A summary is probably shorter than the original text. You'd really hope so, otherwise the linguistic definition of summary is not held up. We like to be highlighting key ideas. A lot of people have written about this before, but I'm going to borrow Raman 2003 when I mean that. And I'm going to claim that a summary should also aid a knowledgeable reader in reconstructing the original proof. I say a version of the original proof because unsurprisingly, if you lose some information and try and go back, you might somehow take a different branch, and every theorem can be proven in, well, theoretically, an infinite number of different ways. Okay, let's get more theoretical now about proof summaries. This first bullet point lives in comprehension land. Well, that citation looks like myself and Ian Jones claiming comprehension. That's not the case. That's Anna Svard and not us. But so I think about these proofs when they're being judged as discursive narratives up for endorsement. So the judge is doing the endorsing, and they are going to come in and make these binary decisions. And what we're trying to understand is what that endorsement process looks like. What do they value, what do they not value, etc. Earlier I had a slide on proof comprehension, or on the proof literature, and I split it into construction and comprehension tasks. This follows a review of Matthew Inglis and Pablo Miaramos. This task kind of defies that binary a little bit, because, okay, sure, it's a construction task, you're writing something novel on the page, but it's also a comprehension task because it's literally based on something that you've read. So it kind of lives as a hybrid between those two things. And this last bullet is somehow married to the same claim that I made earlier about the pedagogic value of writing summaries. I'm not going to dwell too much into that, but somehow I'm going to claim that a spectrum of rigor exists. At one end, perhaps a very, very formal or even a computer proof. At the other end, me and Tanya sitting upstairs with a whiteboard just bouncing ideas off each other. And somewhere in the middle might be a proof that you might see in a journal. I'm going to claim that a proof summary lives at the informal end, or the less rigorous end of that spectrum, but certainly belongs on that spectrum, and we can think about the discursive narratives that we tell each other as all of them living on the same spectrum. Okay, cool. That's a lot of theory-heavy stuff. Let's actually do some more interesting research. So we've talked about proof summaries, we've talked about comparative judgment, we've talked briefly about proof comprehension. I'm yet to define reliability and validity, but bear with me. And then we're going to actually talk about some data. So here are our two research questions. Here I'm talking about reliability, meaning two statistical metrics. Do we all agree with each other? If Phil does some judgments and Caroline does some judgments, are they in fact going to be the same decisions? We'll talk about how those metrics can unfold. And then, okay, sure, if they are making the same decisions, so they are reliable, then validity, are they in fact making decisions based on things that we care about? So are those decisions valid, or are they in fact a reflection of students' handwriting, or their perception of students' cultural backgrounds, or their guess about what colour the student's t-shirt was on the day they wrote it? To do so, we're going to compare the scores that we get to some existing metrics, and we'll also do some more mixed method analysis where we'll look at the content of student summaries and try and predict their score based on the content of what they write. Okay, so that is on one side of your handout. I invite you to read it now. If that is intimidating mathematics that you're not familiar with, that is totally fine. We are not going to get mathematically detailed. This is, for those of you that do recognize it, this is Cantor's diagonal argument for the uncountability of the open unit interval. This is not something that would typically be covered in a first-year analysis course, but you would hope, well, I would hope that most first-year analysis students would be able to make some sense of this proof. On the back side of your handout is this slide, which I've given to you because that is almost impossible to read. This is unfortunately a screenshot of a scan. That's the best I've got for you today. But perhaps those of you that do understand the proof or have some familiarity, you don't need to be looking at this. You're more than welcome to look at the handout. It's probably going to be easier. Fair play. You're welcome to look at whatever you would like. This is not my judgment to make. What I would invite anybody who would be interested in is making this decision. So we're going to spend a couple of minutes talking about which of these two summaries is better. This is exactly what we had judges do. So I'll give you up to 60 seconds to have a think. Even if you don't understand the math, that's totally fine. You could still perhaps try and identify some aspects of a summary that you value, or somehow generate an opinion for yourself. If anybody would like a stack of 30 of these handouts to take home, you're welcome to. Has anybody developed any kind of an opinion on which one of these two they'd prefer? If you know that I know your name. Yeah, go on, Caroline.
I think the, I don't know, I think the one on the left seems more like study notes if I had to memorize the book.
Mm-hmm.
They have a whole lot of things that are like, oh, I remember how to construct it. This is what I should write down. Whereas the one on the right seems to be the plot.
Mm-hmm.
More like this is kind of what's going on. But it doesn't necessarily tell you how to, all the details.
Right, and crucially, we didn't tell the students by design what we meant by a good summary.
Yeah.
But if I pushed you for an opinion?
I like one on the right.
Cool.
Unless I was preparing for an exam.
Sure.
Maybe, I don't know, maybe the one on the right is still.
Well, that gets to a really interesting point that we might talk about later, which is this notion of summary for whom, right?
Right.
If it's summary for an assessor or for somebody else, maybe for a friend, you'll probably write something meaningfully different from exactly as you say. I've never heard the phrase study notes on this left, but yeah, that fits for me. Anybody feel differently? The first thing for me that jumps out on this left-hand side before I express an opinion, which I don't really have, is that the student on the left has more or less just deleted all the words. They've just kept the symbols and deleted the words. Is that a meaningful summary? Potato, potato, I don't have a strong opinion there. But it's certainly not what we expected would happen. The right-hand side is much more of a typical summary. Okay, it's words, it's somehow a narrative, it helps me perhaps reconstruct. I choose this one for a particular reason. So I mean, this is a particularly difficult pairing that is relatively divisive. If I'd given you more time to study the proof, you might have noticed there's a couple of complete nonsenses in here. Why is this? There we go. This doesn't mean anything. B does not equal F. B is a number and F is the function. Presumably what this student means is that B does not belong to the range of F, which, okay, sure, maybe you could claim they knew that and they've written this as shorthand, but I am skeptical. Similarly, in this top right, this 1 over 2 to the k is also somewhere between a shorthand and a mathematical nonsense. What they're actually talking about here is this set here. I don't know if you can read this, but it's the set of all numbers 1 over 2 to the k such that k is an integer, or a natural number, sorry. Whether we're willing to cut some slack on this is an open question. When we ask mathematicians, what do you think? We ask judges, what do you think? They're very much split on whether notation matters. But this is just a flavour of the kinds of things that you'll run into when you're making your decisions. So methodologically, what did we do? Well, we had 143 of these things. We had 11 judges. They're all PhD students. In a parallel study, we also had them judged by research active mathematicians, and the data changes almost not at all. So we don't do that anymore because grad students are easier to find. They all talk about 20 seconds per judgment. That's kind of interesting that they only take that long. Okay, sure, you speed up, but this is a lot of information to take in 20 seconds. But if you've read the proof in advance, you've spent quite a lot of time thinking about what you think a good proof will look, or good summary will look like, which once you're 10 or 20 judgments in, you presumably develop some of those opinions for yourself. Perhaps 20 seconds is reasonable. And we end up with a whole bunch of binary decisions. We put them through the Bradley-Terry model and we generate a score. That's this thing here. I'm calling it the summary task CJ-based score. We have 2 other metrics for students' understanding of the proof. One is a multiple choice comprehension quiz. This is from the crew at Rutgers University in New Jersey in the US. This is, at least for us, our benchmark, reliable and valid metric of whether students understood the proof. This is research that's taken, coming up on a decade now. One of the reasons that I really like this is because of how detailed their methodology is in developing these multiple choice questions. One of the reasons that doesn't just address the whole research question for me is that they've taken, I think this project has now been live for 12 years, and they have 3 quizzes. So they can now address, after 12 years, 3 different proofs. They've got 6 or 7 that are, oh, I'm so sorry, I didn't know that was even on. Yuck. After they've got 6 or 7 more quizzes coming out, hopefully within the next year or so. But somehow this is not a fast, efficient mechanism. If the summary task works, and we can all define differently what we know works, but we can then export that around the educational universe without any more careful thought. That's quite an ambitious goal, but this is one of my motivations in relation to this work. And then, okay, sure, they all came from this analysis 1 module, this first year analysis module, so we might as well look at their performance on their exam as well. Before we do any of that, here are some of the ones that people thought were good. Just give you a few seconds just to have a peruse. Ignore those codes. Those codes will become meaningful later. At the risk of giving away some results, a couple of things you might choose to notice is that these are the top ones. These are the ones that came out at the highest end of the ranking after these binary decisions. These are all narratives. These are all, in a more traditional sense, these are all very wordy. They're all quite easy to read. They're quite clean. They all have some notation in them. They all define the function f, and they say something about the number b. The exception is the first one that says we can construct a number from the open unit interval, but they tell me nothing about what that number might look like. But they at least allude to the fact that you are seeking this number and tell you what properties it might have. This is just kind of a sanity check. This is partly to give you a flavour of the data and partly as a sanity check. Are we in fact doing anything meaningful? So we can look at the middle ones. Okay, sure, these are slightly unenlightening. These are not terrible and not as good as the best ones. There's not really much to tell you here. The more interesting sanity check is the bottom three that are in fact more or less total nonsense. There are actually 12 of the 143 that are worse than this, either because they were blank or like one student drew a picture of a tree and one student wrote the statement, prove that, ... and nothing else. Those didn't seem very illuminating, so we've removed them from the data set. But the ones that after that do somehow have some meaningful substance are still by and large not very interesting, and they come at the bottom. So that's kind of our first very informal, you could call it face validity, you could call it the smell test, call it whatever you want. We're doing something perhaps useful. Let's go into more detail. Let's look at reliability. So these are statistical metrics. This first one, SSR, or scale separation reliability, operates mathematically exactly like Cronbach's alpha, to those of you that are more familiar with sort of more traditional statistics. So we're hoping it's above 0.7. It is, so that's nice. Inter-rater reliability, slightly more complicated, is based on split half comparisons. So we split the data up into two halves. We generate a score for each script based on each half, and then we take a correlation between those two halves. And we say, if we split the data in half randomly, are those two halves more or less equivalent? This is always lower than SSR for reasons that I could try and explain, but we'd be doing so flimsily. But it's not that alarming that it's 0.73. It's still above 0.7, and so we can more or less give a check mark, at least to this data set. Importantly, with comparative judgment, we do not assign reliability to the assessment mechanism, but we assign it to the data set. So it's not impossible that if you come and do this again in a different context, your reliability might fall off a cliff. Or be way better, who knows? But okay, let's look in more detail at convergent validity now. So now we're trying to go back to this question, are we doing anything meaningful at all? And that top left box is the one that I care most about. So did our scores replicate something to do with the Rutgers group's comprehension quiz? And we get this kind of irritating result. Okay, so it's significant. This p-value is very, very small. Lovely news. There is some relationship between this and the established metric. But the correlation coefficient 0.28, okay, it's not what we might have hoped. It's meaningful. I mean, this is sort of the dark art of statistics at this point. We'd prefer it to be in the 0.4, 0.5 range to be more consistent with comparative judgment literature that says, yes, this is definitely valid. The comprehension quiz itself, our students did extremely poorly on the actual quiz. Only just, statistically better than chance, but only just. There's four options for each multiple choice item. So if they'd gotten 3 out of 12, then they are literally just monkeys. Okay, sure, it's a bit of a convenient post hoc justification. Well, I didn't get the data I want, but that's because the other metric was broken. Obviously, my metric's perfect. It's not a particularly good argument. But what this tells us is that we're doing something meaningfully interesting, maybe, and let's look closer. We also get a significant correlation with module grade. I don't make a big deal of this one because part of the argument that we make with comparative judgment is we use it when other metrics don't work. And then to say, well, the other metric doesn't work, therefore we need something new. Also, my new thing is great because it replicates the old thing. It's kind of a flimsy circular argument. But it's a nice sanity check that we get a correlation that is significant and relatively low. That's kind of pleasing. That top right box isn't very interesting. That's just checking that the module grade and the comprehension quiz are related. Again, pleasing that it is, but don't care as much as we could. Okay, so what next? So we've got some validity. We're moving in the right direction, perhaps, but we want to know more. So we're going to do some more mixed methods analysis now, where we're going to look at literally what did the students write and which aspects of what students wrote are predictive of the scores that they received. So here we had 2 researchers, one of them is me, and we generated 15 codes in a sort of 3-stage iterative process that sort of resembles thematic analysis in a Broad and Clark sense, but I don't make such bold methodological claims here, because what you'll see if I go on to the next slide, so we broadly speaking agreed and blah, blah, blah. But the next slide here is our coding scheme, is more or less just a breaking down of the original proof. This is somehow just a very overly detailed summary of the proof itself. So more heavy-duty methodological tools to generate this didn't seem particularly necessary. I'll draw your attention to a few things here. This is not particularly interesting, but code 14 is quite interesting. Explicitly stated that F is not surjective as a result of the above argument. That is essentially the whole thing. Code 14 is the whole, it's the big beans, it's the reason the proof works. It's a contradiction proof, code 4. What they are deducing is that we assumed that F was surjective, and we're going to break that, and we're going to demonstrate that F is not surjective. You would really, really hope that code 14 would feature in lots of their summaries. 17%. It does not. Yet more indication that perhaps our students just didn't understand the proof as well as we might have hoped, which is unfortunate. Maybe we gave it to the wrong set of students. However, we don't really care so much about the students themselves. We're more interested in the assessment methodology. So it doesn't invalidate everything we're doing, but it does put little asterisks next to it. But cool, so what do we do with this coding scheme? Well, again, I said earlier, what I want to know is which aspects of their summaries are most indicative of their performance on the comparative judgment task. So we'll go through and look for isolated correlations between were you awarded this code and did you get a high score, or what score did you get on the summary task. We find that 8 of them are significant. They have asterisks. We put them through a regression model. We could have put the whole list of 15 codes through a forced entry regression, but the data set's not big enough to justify that, so we need some way to eliminate things that are irrelevant before we start using regression. So we use this. So here are our 8 codes. We are interested again in which ones are most related to summary score. So we're looking, right now we're just looking at significance value, we're just looking at p-values. Oh, yikes, let's go back. One other thing that I'll draw your attention to is down here, R squared. This is how much of the variance are we explaining with these codes? Said differently, is this coding scheme meaningful? And this is higher than anything I've ever seen or done when it comes to this kind of regression analysis. So we're pleased and we're satisfied that our coding scheme does in fact reflect something meaningful about the data. More pleasing still when we go further into it and we take out just the 4 significant ones here and we look at our final regression model. Okay, sure, R squared is a linear or monotonely decreasing function, so it's not surprising that it's lower. It's not that much lower though. With just these 4 codes, we are still explaining 43% of the variance here. And what are these codes? These are the things that we care most about, perhaps. So proof by contradiction, the literature all over it says, when we're talking about students' understanding of proof, we would like them to identify the method of proof. Code 14, we talked about that already. That is the contradiction, so it's not that surprising that these 2 appear. What are codes 5 and 10? We've also discussed them implicitly. They are the 2 key objects in the proof. So F is this function that we defined to generate a contradiction. How did we find the contradiction, being that F is not surjective? Well, we constructed some number. What is that number? The number is B. So what? Who cares? Maybe nobody. So reliability, we've already claimed that this works. We are measuring something meaningful. What is that thing? Well, I've hopefully just presented some relatively compelling evidence that we are in fact measuring something that is proof comprehension, or students' understanding of the proof that they read. There are many, many open questions. I've left myself time to talk about a few of them. So we've made some implicit sort of value judgments about what do judges look at, or what do they attend to when they make their decisions. But we haven't actually literally spoken to them yet. We don't know what they do or what they think they do in real time. There are other open questions that we'll talk about later, but let me use my last few minutes to talk about a follow-up study where we literally asked, this is a sort of a think aloud protocol, well, we brought some mathematicians into the lab and we asked them to make some judgments in front of us. Well, I say us, right? I really mean me. And we attended to these 4 aspects of what they were doing. So which mathematical content did they care about, if any? Which features, when I say features, that will become clear in a second what I mean. How do they process the information? So you get, like on your handout, you get quite a lot of information that comes up on the screen at once. How do you approach taking all of that in? It's not obvious that everybody does that the same way. In fact, they most certainly don't. And then bullet point 4 is kind of, you could relabel that as miscellaneous. What other things do they think about? So we had 9 judges. They hung out with me in the lab for an hour. Some of them stayed for an hour and a half. Anyone that's interviewed mathematicians, they don't shut up, which is lovely. You get all kinds of interesting data. But if you book back-to-back sessions, you need to leave gaps. Who knew? Traditionally, with comparative judgment studies, we would give everybody different decisions to make, so different pairings. Because we wanted to make some kind of, word repetition's unavoidable here, we wanted to make some kind of comparison between judgments, or between judges, sorry. We gave them all the same set of 20 pairings to look at. And the first thing they did was make 20 judgments with me sitting in the room, but them looking at the screen and we're not talking. They can ask me questions if they want, but by and large they didn't. We then had a semi-structured interview where we asked them about that experience and the kinds of things that they did and why they did them. And then I asked them to repeat 10 of their judgments, so the final 10, 11 through 20. And I asked them to talk me through what they were doing. Sometimes they would just replicate their old judgment. Sometimes they would actually say, oh, now that I think about it more carefully, I'll change my decision. The reason for this ordering is that we didn't want to contaminate their approach to the judgment process. So by having them do the judgments first, we at least hoped that we would get some kind of authentic reflection of what they were actually doing. Okay, sure, this is obviously a proxy for what they were actually doing, but this is our best attempt at getting one. I'm going to skate through this in the interest of time, but so these are the kinds of questions we asked. You'll notice that first up we asked some quite generic questions. How did you find it? How did you make your decisions? And then, okay, later on we're sort of testing some more concrete hypotheses or more concrete ideas. Did you label any responses in your head as good or bad, or did you know that that was a benchmark as that's the best one and therefore everything that gets paired against it is worse? Did you care about length, etc.? Thematic analysis, in the interest of time, I'm going to skate over the methodology there. We did a pretty traditional thematic analysis style approach. One thing we also added to the methodology of Braun and Clark was this notion of analytical summaries. For each judge, we wrote up a very brief, based on the codes that they had been assigned, just a very brief summary to guide ourselves around the data when we were looking back at it, because it's quite a large data set. And whether you believe me about how I got here, this is where we got to. So these are the 6 themes, or the 6 broad categories we identified as influencing the way that judges make their decisions. I'll draw your attention to a couple of them, but I'll give you a few seconds to have a look at it. The ones that are most interesting to me are top right and bottom left. I'll talk about top right first. This one is a selfish motivation. I'm pleased that they explicitly talked about the construction of B, the construction of F. They talked explicitly about the method of proof or about contradiction. Why is that pleasing? Well, in our earlier analysis, we somehow had this statistical indication that these are the things that they cared about. Qualitatively, they in fact do talk about these things. So, yay, we were right. It's a pleasing conclusion from there. From the bottom left, these plus minuses are a little bit opaque, but I'll unpack that a little bit. When I say plus minus here, it doesn't mean that some referenced it and some didn't. That would just be a regular code. This means that many people referenced it in both directions. So technical detail was very, very important to me. Or I could not care less about technical detail. That's not the point of a summary. Or when it comes to mathematical precision, in fact, I can actually show you a couple. I do have some time. So one judge, it really depends on the notation. That's a big bugbear for me. I really, really care about how precise they are with each piece of notation that they use. On the other hand, I'm quite used to cutting some slack on notation, particularly with students at this level. It's just not that important to me. I'm kind of willing to overlook all those things. So if I take you back, so mathematical fluency is a similar one that some people talk about it being very important, others don't. So there's a whole bunch of different things where we get these plus minuses. However, despite all the various motivations and various approaches, the way people think about these things, by and large, just as we had reliability earlier, people agree on which one is better. Okay, sure, you might be skeptical of that because the one example that I asked you to do was a particularly difficult one. That was to hopefully generate some discussion. But by and large, if I give you 2 summaries in the same way that if I give you 2 pens and I ask you which one's heavier, if I give you 2 proof summaries and ask you which one is better, you might have a different motivation for choosing it, but almost always you will agree with me and you'll agree with your neighbour and you'll agree with whoever else you care to ask. That, to me, is interesting and is important and somehow suggests that we are doing something interesting. From a more theoretical standpoint, so this confirms that comparative judgment is useful in contexts where consensus is hard. I claimed very glibly earlier that proof is one such place. There's a whole philosophy literature on that we could talk about, but I invite you to ask me if you'd like to. But this suggests that comparative judgment is this is a productive use of comparative judgment. It makes sense to do so here. I'll draw your attention down the bottom. This is kind of some borrowed language from either from Cognition land or from a paper by Paul Dawkins and Keith Weber about values and norms. Okay, sure, perhaps it's the case that there's something underlying that we all just have this sense of, whether we want to call it mathematical fluency or we have some shared discourse around what good mathematics looks like. It's quite hard to put our finger on it. If I asked you to write down what good mathematics is or good proof writing looks like, you'd probably do so poorly, but somehow we do have some agreement here. And this is, by and large, the claim of Jen and Keith here. This is a very, very interesting paper for anyone that's interested in proof, trying to conceptualize proof not as a kind of criterion-based, here are the things that make a proof, here are the things that disqualify an argument from being a proof, and arguing more nebulously that perhaps a proof is productively viewed in sort of this more Wittgensteinian sense as let's talk about it as a cluster account of what proof looks like. This is a highly theoretical paper. In some sense, you could argue that the research that we've just done adds some empirical backing to the theoretical work of Jen and Keith. They're talking about proof. I'm talking about proof summaries. I'm going to claim that, at least in this context, these two things come together. These are both going to be cluster concepts. That's a very brief summary of what I've just talked about. And how long do I have? 9 minutes. Perfect. So some future work or some different ideas about where this might go. Everything we've talked about so far was about exactly one proof. In some sense, this is a very big, elaborate n=1 study. Maybe that proof somehow has some unique properties, or I chose it particularly well, or I got particularly lucky. So, okay, we need to look at some other ones. This paper that is hopefully going to be submitted by the end of next month looks at 9 different proofs and more or less plays the same game, just extends the methodology that we've just talked about. And the slightly glib highlight of that paper is, by and large it works in other contexts. Other early undergraduate proof contexts. I talked about this very briefly earlier. We might do some more systematic investigations on what it looks like, and do students really benefit from doing this thing? I suspect that they probably do, but I don't really have any good evidence to claim that, so I would like some, or I'd like to be proven wrong. So one thing we're doing at the University of Edinburgh is we've embedded a weekly summary task. Apologies. We've embedded a weekly summary task for 300 students on a proofs and problem solving module. And we will do a series of interviews asking them what that experience looks like, as well as tracking their progress throughout the semester. Okay, I've now done this at 3 different universities, but they are all largely white, English-speaking Christian countries. It's not obvious to me what this looks like in other places, whether summarizing is a meaningful endeavor outside of those contexts. Again, I suspect that it is, but I don't have any way to argue that. So I would like to be able to extend this research to some other cultural and geographic contexts. And then finally, think more carefully about how does this task, if it does have a place in a classroom, and again, most of the work I presented today is more theoretical, pure science type work. But if it does belong in a classroom, where does it belong and to whom, and what benefit does it have? Does it mesh well with existing assessment forms? Could it be a standalone thing? I suspect not. Where does it belong and why is that a good idea? But so those are some places that I intend to extend this work. Some of them I'm already doing, and others are more nebulous ideas about things I would like to do in the future. And that is me and my friends and my boyfriend here on Mount Cook. And thank you very much.
Thank you very much for a great presentation. It's amazing how much research actually has happened. It's impressive, really. I don't know much about proof summaries, but it's very intriguing to me. So what is known about their pedagogical value so far? How did you decide to limit it to 40 words, for example? How did you
this is interesting. The short answer is nothing in terms of what is known. The longer answer is that the goal was actually a comparative judgment-oriented goal. The goal was about generating diversity in responses. We feared that if we gave them too much freedom or just asked for a construction of a proof, that we would get either some kind of bimodal, where there's good ones and bad ones, and okay, deciding between two good ones is hard, and deciding between a good one and a bad one is boring. The 40 words was an experimental. It's a flimsy answer, but the honest answer is we tried 60 words in a pilot, and we decided to shorten it. Whether that's optimal is not at all obvious. In fact, it's almost certainly not optimal. But the notion of proof summaries is new. I mean, okay, sure, we're not the first people to think about the notion of summarizing as educationally beneficial, but in the context of proof, I'm not aware of anybody else using that idea. Sure.
One of the things that I'm looking at is aesthetic evaluation, and this seems to marry up really well with that. And one of the things I wanted to ask you is about, did you test for transitivity, and did you test the same people across time to see if they gave similar answers?
Very interesting. 3 answers. Transitivity, not directly, but in some sense, Cronbach's alpha, or SSR, is a metric of transitivity because it's looking for consistency within the decision matrix. So if you find triangles that are non-transitive, that's going to bring down your SSR. Sorry, I've lost my time 1, time 2 testing. No, we haven't looked at that. I know in other comparative judgment settings people have, and not found anything particularly interesting beyond, don't worry about it. And the third is that there is some really interesting work happening at Loughborough right now. I'm sure you're aware of Matthew Inglis and his work on aesthetic, but he's got a grad student, Tuya Sa, who is doing some really, really cool stuff, trying to identify whether aesthetic exists. I mean, okay, sure, this is people have written for years about how it may or may not. That's not my interest. That's not my professional research background, but I'm fascinated by that stuff. So I would suggest you reach out. If you want to drop me an email, I can put you in touch. Fiona Townswell is another one that you might reach out to.
Ben, thank you very much. You've got some interesting challenges ahead of you. That's enormous. Thank you. Thank you for sharing your time with us.
Thanks.
Thanks, everyone.
Thank you.